Hey guys, I'm going to review everything that we've been doing the past couple weeks for your activities the next 2 days. Since I'm not going to be here, I'm going to try to help you out through these videos. The first thing we're going to talk about are angles. Remember, complementary angles add up to 90 degrees, okay? So for example, you could have something like 81 degrees and then another angle that's 9 degrees. Well, since those two angles add up to 90, those are complementary angles, okay? Only difference between that and supplementary is supplementary adds up to 180 degrees, okay? So, with supplementary angles, you could have something like, 50 degrees, and this would be 130 degrees. Okay, those are supplementary angles. Vertical angles, if you've got two lines that intersect, the opposite angles of each other, the ones that mirror each other, are vertical angles. Now, that's not to say you couldn't have something like this. What if we split this angle? Okay, well, this little part here is not the vertical angle to this angle. Okay, you've got to think, what makes the vertical angles? Which two lines are the two that intersect? Well, it's this line right through here and this line. So you got to look at anything from this line to the other line that intersects all the way across. Those are vertical angles. Okay, if these are the two lines that intersect and go all the way through, then those are the two vertical angles with them. Okay, that's a real quick rundown of complementary, supplementary, and vertical angles. Remember, vertical angles are the same. Okay, so if one's 50 degrees, the other one's 50 degrees. Okay, we're going to start with the second problem we worked in class today. Okay, the house. Okay, or I believe it looked like this. Okay, I was completely wrong. This is actually what it looked like, where this side was 12, this side was 15. Now, remember, we tried first to draw a line straight across to create shapes we know. Well, it made a rectangle, right? And this was 24 down here. Made a rectangle, but we don't know this shape, okay? Well, then we tried, maybe we could cut this into a triangle itself. Well, this makes a right triangle, which we could find. The issue is we don't know enough about this triangle. It might be a right angle here, but we don't even know this height anyway, so it doesn't really matter. Okay, so that's not going to be the way we can cut it up. Alright, so we decided the best way to cut it up would be to go down the middle. Or not really the middle, but go down at this direction, right? Okay, now we noticed from here you could make a triangle here. And you can make a triangle here. Now, we know these two right triangles, we know these two rectangles, so we're good. Now, somebody earlier today also did this, made it into 3 rectangles. That's fine. It's still going to add up to the total area if you find all those shapes. Okay? Somebody else today, I believe, drew it all the way across here. Made a triangle there, a triangle there. Actually drew this. I think that's actually where they stopped, right here. Okay, we still know this too, right? We can find this. Okay, 12 by 24. We can find that. This would be 3, on this side. Okay, you just got to find the missing side links at that point. Okay, it's just a puzzle, right? Now, somebody else today thought of this a different way, which is great. They turned it into a rectangle. Okay. They knew it was a total of, I believe it's 22 here. They knew it was 22 feet long, 24 feet wide. So they took 22 times 24, then found the area of these triangles. Well, they knew if this was 22 total, this was 12 here, then this needed to be 10. They knew if this was 15 total and this needed to be 7, or if it was 22 total and this was 15, that needed to be 7. They knew if this was 15, this part needed to be 9. Okay? They found the area of that triangle to be 31.5, the area of this to be 75. Okay? So they took 22 times 24 to get the whole big rectangle all the way around that they created. Okay, whatever they found the answer of that to be, they took away 75, and they also took away 31.5, and it got them to 421.5, which is what the answer was. Okay, so that's another option you can do. You can turn it into a rectangle that you know and take away what you don't have. Okay, all kinds of different options with these. Okay, so a few things to remember about triangles. The best triangles to work with, right triangles. Because if it's a right triangle, then you definitely know the height and you definitely know the base. Okay? Because this is the height is the right angle from point to point. Okay, remember these are a little iffy to work with. Okay, sometimes you don't know these. Alright? You need to know this height. Right through here. You need to know that 90-degree height. And if you don't know that, then that's not a very good triangle to work with. Okay, so real quick, I'll sketch another thing somebody did on that shape we had before. I forgot to point this one out. This was a good one as well. Okay. This is what they made it into. Okay, so since it was 22 total, and this part was 15, I believe. No, this was 15 up here. Sorry. Okay, this was 24 down here. This was 12. Okay, now, I know it's not the best drawing, but I just want you to see this idea. They did make it. They knew this was 15 over here, so they knew the height of this triangle had to be whatever was left from 22 when you take 15 away, which is 7. The height of that triangle is 7. They knew the base all the way across. Well, since it's 24 all the way across, you know, and they know this part's 15 up to here, and they know this part then has to be 9, and it actually should split down the middle. They know that what's left of this is 9. 9 plus 9 equals 18. They know that this needs to be 6. Okay? And then they found it from there. Okay? Again, guys, there's all kinds of different ways you can cut these triangles, these shapes, these compound shapes up. Okay? That's what I want you to understand. There is no really right or wrong way. You just need to make sure that you cut it up into right triangles and rectangles. That's the only two things you know right now. Right triangles and rectangles every time. Okay, so here's another shape we can do. Okay, let's think about what we know here. Well, it's pretty obvious. Some of you guys worked part of this in class today. It's pretty obvious that you can make a triangle and a rectangle out of this, right? Well, we already know 5 by 4 here. So the area of this part's 20, right? Now we got to think about this triangle. Well, we could make it a right triangle by splitting it right down the middle and finding this height. If the whole thing is 10 all the way across, this rectangle part's 5, that leaves this height to also be 5, because 5 to here and 5 more makes 10 all the way across, right? Okay. We also know that from this top point to this bottom point is 8, right? So that is the base of this. The height is 5, the base is 8. Okay, so you got, remember, area of a triangle is 1/2 base times height. If you don't remember why, think of a square or a rectangle. Okay. To find the area, it is base times height to find a rectangle, right? Or length times the width. Well, to turn that into a triangle, all you got to do is go from one corner to the other, and that is now half of the base times the height, right? It's no longer the whole base times height of a rectangle, it's just half now. Okay? So, that's where area equals 1/2 base times height comes from. So our base is 8 again. Okay, so the area of the triangle is 1/2. Base is 8. Height is 5. Okay? I would always recommend multiplying the base times the height first. Okay? That'll just help you out in the long run, because then all you have to do is just cut it in half or divide by 2. So what's 8 times 5? Well, that's 40. So now you got 1/2 of 40. Okay? And the area of that part is also 20. Okay? So we've got an area of 20 for the rectangle, an area of 20 for the triangle. Total area is 40. Okay? Now real quick, we're going to go over scale factors. Remember, this is similar to the example I gave you in class today. Alright, we'll say this is shape A. We'll say this is shape B. Now what if they say A to B is a scale factor of 1 to 1/2, for example, and they give you 10, 15, okay, and then they give you a missing number and a missing number. Well, what's x going to be? Okay, well, if it's 1 to 1/2, one of these to a half of it here, x would be half of 10, 5. And again, 1/15 to half of a 15 here, y would be 7.5. Because 7.5 is half of 15. Okay? Now remember, another way you can look at it is, what if they give you something like 8 and 9? They give you a shape. It should look the same. Sorry, I didn't do too well on that. Let's say they give you 2 here, and they want to know what's the missing length. Well, you can set up a proportion, right? 8 to 9 is equal to 2 is equal to 2 to some number, right? 8 to 9, that's the relationship here. What's the relationship to 8? What has to go in the same spot as 8? The 2, because it's in the same spot on the rectangle as 8. What has to go in the same spot as 9? The x. Okay, so now you cross multiply. Okay, now you get 8x equals 18. One step from here. Divide both sides by 8. X equals, what is 18 divided by 8? Well, you got 2 whole, that gets you to 16. 2 and 2/8 left over, which is the same as 2 and 1/4. So this missing side would be 2 and 1/4. Now remember, you can't just take away 6 from 9 because they took away 6 from 8. Okay, 8 minus 6 is 2. 9 minus 6 is 3. Okay, let's look if that's proportional. 8 to 9, is that the same as 2 to 3? Does 8 ninths reduce to 2/3? No, it does not. So that is not a proportion. Okay? It's not proportional, that means it's not a similar figure. 2 and 1/4 makes it a similar figure. Okay? So, how can you tell if two shapes are proportional? I'll use letters this time. Well, here's one way. You could do A to B has to be proportional to what matches with A, E, what matches with B, F. And then you can cross multiply with numbers, and if you get the same answer for both, then yes, it is proportional. Okay? Another way you can do it is reduce both fractions separately. If they reduce to the same fraction, then it is proportional. And last but not least, you can also divide, because a fraction really means divide, right? So if you divide and get the same answer on both sides, they are proportional. Alright, I hope this helped you out a little bit. Good luck on your assignments the next 2 days. I will see you on Tuesday. Have a good weekend.